Good afternoon. This is Rich Nass with Open Systems Media here for this week's installment of 5 Minutes With. This week, I have the pleasure of speaking to Larry Lapides of Imperas Software. Good afternoon, Larry. How are you?
I'm doing great this afternoon, Rich. How are you?
I'm doing fine. You sound like you're a little shy there. You need to speak up, and don't be afraid to voice your opinion in this interview, okay?
Sure thing.
Okay. You are, now I don't even know if you know that I know this about you, but you are one of the people who is a proponent of RISC-V, the architecture that is, it's an IP, and I liken it to ARM IP, whether that's right or wrong. That's the way that I look at it. But, well, let me start there. Is that a fair way to characterize?
It is a fair way to characterize it, although there are some key differences. So I think the first key difference is that the RISC-V instruction set, the RISC-V architecture, is open source. And so for anyone that becomes a member, for any company that becomes a member of the RISC-V Foundation, they have access to the architecture, they have access to the tests, and they can legally say that they have a RISC-V compliant processor in their device. So that's a bit different.
The ramifications of what you just said are far beyond the scope of a 5-minute interview. Let's suffice to say that it's huge.
It is significant. The open source component is interesting, I think, in three ways. One is that companies get to have a say as part of the RISC-V community in the specification of the architecture. The second is that there's a financial component to that, a lack of royalties being paid, which can be pretty important in some vertical market segments. And then the third thing is that there's also a growing open source community that are open source proponents philosophically, not for the control aspect necessarily or the financial aspect, but because of the benefits of the open source community.
Okay, I don't mean to put you on the spot, but you said there are many instances where paying royalty fees is significant. What's an example of one that it's not significant?
Well, I think potentially at the high end of devices, for example, if you're looking at the server market, you're looking at high-end processors, high-end chips, then your device costs are going to be higher, and so the royalties may not matter so much, and the volumes are not extraordinary necessarily. On the other hand, for RISC-V, where at least the initial applications, the initial verticals that it will most likely be used in are IoT or industrial electronics, then you're looking at tens of millions potentially in terms of volume. And if you're looking at that and the prices for different IoT nodes, then even pennies of royalties can be significant. So I think there's a contrast there.
Okay, I didn't mean to put you on the hot seat like that. That was not my intention.
No problem, Rich.
Okay. The last point that I'd like to bring up, which is a really significant one, regardless of how great RISC-V is from an architecture perspective, if you don't have an ecosystem around it, you pretty much have nothing. Is that fair? I mean, that's certainly my opinion, but is that a fair opinion? And is there any ecosystem around RISC-V? And what's the future hold for the ecosystem around RISC-V?
So it is a fair assessment. Actually, I think it was about 3 years ago, ARM commissioned a book that focused on the ARM ecosystem and talked about the ecosystem as a business model. And so to say that RISC-V is going to succeed or potentially fail based on the ecosystem is a valid point to make. So in terms of the current RISC-V ecosystem, I think we need to look at it in terms of potentially three different pieces. One is the hardware flow, and essentially that's EDA tools supporting RISC-V. And there is existing support from the big EDA vendors. There's also from a high-level synthesis perspective, there are a couple of vendors that are supporting it there, more from a processor IP perspective than anything else. Mm-hmm. And there's that gets us to the second piece of the ecosystem, which is the implementation of a RISC-V core, the actual RTL or the silicon implementation from there. And again, these there are, I think, at least three different companies right now that have a high-level synthesis flow that allows you to customize the implementation of your RISC-V processor and deliver RTL or even lower-level code into the SoC flow. There are also now 3 or 4 different companies that are providing RISC-V processor IP, essentially RTL, that can be implemented. And so there is an existing ecosystem on the hardware flow side and on the processor IP side. The place where RISC-V is a little light in the ecosystem is on the software side. And actually this is, I think, ARM's great strength. It's not just the ARM technology itself, but it's the software ecosystem. And what RISC-V needs to do to be successful is to make it easy for people to port and bring up code, whether that's operating systems or drivers or firmware or libraries. Needs to make new code development, new software development easy on RISC-V platforms. And because RISC-V is most likely going into markets where reliability, quality, safety, security are key factors, the software test is key. And so there are some companies, my company, Imperas Software, being one of those, that are members of the RISC-V Foundation and starting to contribute to the software ecosystem for RISC-V. I think this is a current weak point for RISC-V, but one that's being worked on actively. One of the things, just to point out where the foundation is, the executive director of the RISC-V Foundation is giving a talk at the upcoming Design Automation Conference. A third of that talk is devoted to the RISC-V architecture. A third of that talk is devoted to the tool chain for RISC-V, the software tool chain, compilers, debuggers, and the like. And a third of it is devoted to operating systems and other software running on RISC-V. So 2/3 of a RISC-V talk at DAC focused on the software side of things. So this is certainly an active area for the RISC-V Foundation and its members. Very good, very good. I'm afraid we've used up our 5 minutes, so we'll have to stop there. But suffice to say, this is a pretty cool and up-and-coming technology. Well, thanks for the opportunity to talk about RISC-V, and I hope this is useful and valuable to your audience. I definitely think it is. That was Larry Lapides of Imperas Software, and I'm Rich Nass with Open Systems Media. Have a great day, Larry. Thank you, Rich. You too.